This video is for page 16 of your interactive notebook about subatomic particles. Following the discovery of the nucleus, scientists began the search for the positive particle that it was made of. You'll recall that in the Marsden and Geiger gold foil experiment, we discovered that atoms, instead of having a diffuse positive charge that was spread throughout the atom, the positive charge was located in a central, small, positive nucleus. So when they went searching for the particle that made this up, they instead discovered not one but two different nuclear particles, giving us a total of 3 subatomic particles. One of the subatomic particles is the electron, which we already know about. The electron is a very small negative particle with almost no mass. This was discovered by J.J. Thomson in his famous cathode ray tube experiment, and the number of electrons in an atom is going to be equal to the number of protons in the atom if the atom is neutral. One of the 2 nuclear particles that scientists found was the proton. Protons are positive particles in the nucleus of an atom. They were discovered by Ernest Rutherford in 1920, and they're going to be equal in number to the number of electrons. Again, this is true only for a neutral atom. When we talk about ions, the number of protons and electrons will be different. The atomic number, often represented by the letter Z, is the number of protons in the nucleus of an atom, and each element will have a different atomic number because the atomic number and the number of protons in an atom determines which element the atom is. Each proton has a mass of 1 AMU, which is an atomic mass unit. The particle that scientists did not expect to find but did was the neutron. A neutron is an uncharged, neutral particle in the nucleus of an atom, and this was discovered by James Chadwick in 1932 when he did some experiments to determine what the other particle that came out of the nucleus was, along with the proton. The neutron, it turns out, also has a mass of 1 AMU and is a nuclear particle, and we can calculate the total mass of an atom by adding the number of protons to the number of neutrons, since those are the only 2 particles in an atom that have a significant amount of mass. Remember that electrons won't factor into this because their mass is so very small. On the left side of your notebook, we're going to draw a beryllium atom, and this is like a Rutherford atom like we saw before. In the middle, we're going to have protons and neutrons. The protons here are blue and have a positive sign. The neutrons I've represented as green circles, and there is no sign because they have no charge. And surrounding this are the orbits that the electrons are in, and each of the electrons is a small negative particle around it. Now you'll notice that this is not to size. In fact, not to scale. In fact, the electrons are significantly smaller than a proton and a neutron. But this is just a model, so we have to suspend our sense of scale at least for a little bit so that it all fits on one page. If you look at the periodic table, you'll note that the atomic number for beryllium is 4. That means that I have 4 protons, and if I assume that this is a neutral beryllium atom, I also have 4 electrons. The atomic mass number for this particular beryllium atom is 9. So if I use the formula atomic mass number is equal to number of protons plus the number of neutrons, I can calculate that the number of neutrons must be 5, since 9 minus 4 is 5. The last thing that you'll do on this page is glue in the atomic structure practice worksheet. We did the first table in class, but I want you to do the next 2 for homework. And for each of these, you're going to fill in the name, atomic number, atomic mass, number of protons, electrons, and neutrons, and write an isotopic symbol. Isotopic symbols are actually covered in the next video for page 17, but they're also discussed at the top of this page. Finish that and glue it into the left margin, and you'll be done with page 16 of your interactive notebook on subatomic particles.